some of the things that have gone on recently, like what's happened with electricity prices on the East Coast versus well throughout the rest of the U.S. What's happened with gas prices in each of the major control areas or each of the major uh, yeah grid areas?
No worries. In recent times, we've seen a bit of a divergence. On the East Coast, natural gas prices have been higher, partly due to pipeline constraints and demand spikes. That drove electricity prices up more sharply there. Meanwhile, in areas like the Midwest, MISO territory, or Texas ERCOT, gas prices were a bit more moderate. They've also had more wind and solar, which help offset some costs. In short, where gas is tight and infrastructure is constrained, prices jump faster. Where renewables and supply were steadier, costs rose, but not as dramatically. A reminder that geography and infrastructure shape the energy story.
Now wait a minute. You brought up something very interesting that I wasn't I wasn't going to discuss in this, but right now they're pushing for more gas in the Northeast and the East. Um, are you saying that it wasn't IBRs that caused the pricing to go up? And by the way, I'm being a little sarcastic. So it wasn't the IBRs, which are not prevalent in the East Coast, that drove prices up?
Exactly. The irony, right? It wasn't the renewables, they're less dominant there. It was the reliance on gas and infrastructure bottlenecks. More gas without new pipelines, that just means more price spikes. So, IBRs were not the culprit. In fact, they could help smooth things out. A little sarcasm is fair, given how often the narrative misses the mark. Reality's always more nuanced.
So when we talk about that, what happened as a result of shutting down offshore wind?
Well, shutting down offshore wind or delaying it means we lose a potential steady, local source of power. That can mean more reliance on fossil fuels, driving up prices when supply is tight. It also means missing out on a chance for long term price stability, since wind has no fuel cost. Essentially, it's like skipping a chance to diversify your energy diet, leaving you more at the mercy of gas price swings. In short, less wind, more volatility.
And how much offshore wind was has been developed and was paused? I believe it started again. Correct me on that if I'm wrong. How much power are we talking about, and what percentage of that is it on average? Thinking in terms of also capacity factor on the East Coast.
You're right, it's restarted, but some projects face delays. Offshore wind in the Northeast was aiming for gigawatts, think multi gigawatt capacity. A gigawatt can power hundreds of thousands of homes. Capacity factors offshore are often around 40 to 50%, higher than onshore wind. So when paused, it was a significant chunk of future planned supply, enough to nudge the region toward stability.
Well, let's talk also about the offshore power that was about to feed Dominion Power, where our largest data centers are in Northern Virginia, near Washington D.C. How many gigawatts of power was planned there, or is planned there, and what percentage of the load would that have dealt with, considering also the capacity factor for that area?
Dominion's offshore wind plan was aiming for around 2.6 gigawatts, with a capacity factor near 40 to 50%. That's roughly like a steady 1 to 1.3 gigawatts on average. In Northern Virginia, where data centers are colossal loads, that would cover a big chunk of that growing demand, helping offset pressure on the grid. So that offshore project wasn't just about general supply, it was about supporting the digital giants, reducing reliance on other pricier sources.
And the direct result of that would have been what on energy prices over this last period where costs went up significantly. Now think in terms of both or the two major area projects, Northeast and offshore Virginia.
Had those offshore wind projects fully online, they'd have provided a stable supply of low marginal cost energy. That means during recent price spikes, driven by gas constraints, electricity costs would likely have been moderated. In both the Northeast and Virginia, they'd have acted like a hedge, reducing reliance on pricey gas and adding predictable capacity. In short, prices would have been less volatile, helping shield consumers from some of the steep increases we saw.
So, and by the way, folks, I didn't plan this part of the conversation at all. So there's no prep behind this. This is stuff coming directly in. So, thank you, June. But in any case, so what you're saying is even though the cost per megawatt hour projections for, say, MISO and JPM were similar during the last summer, um, we didn't see a price hike in the MISO area or a significant one, but we did on in the JPM area. What was that attributed to?
Exactly. MISO, with its broader resource mix, including ample wind, had more supply flexibility. Meanwhile, PJM's price hikes were largely due to gas constraints and higher demand. Without as much wind or additional supply relief, PJM was more exposed to gas price fluctuations. In other words, similar projections, but MISO had a better cushion. PJM's tighter constraints amplified the cost spikes. Geography and infrastructure matter.
So if we drive more gas into the Northeast instead of working on that other mix, what potentially will happen on the East Coast? Forecast it.
If the Northeast leans even harder on gas without diversifying, it risks repeating the same story. Volatile prices whenever supply tightens or infrastructure lags. It's like putting all your eggs in one basket. When gas prices jump, so do costs. A balanced mix, more wind, solar storage, adds flexibility, lowering risk. Without that, the East might face more roller coaster pricing. Forecast, more gas alone likely means more price whiplash.